Okay, example 2. This is exactly the same as what we've already done. Converting from polar to rectangular coordinates. If you recall, the polar form gives me r and theta. And the h part, and we're going from to rectangular, is hi plus vj, right? The h part is r cosine of theta, and the v part is r sine of theta. All right. With that in mind, the angle's negative. That's how this is different. Make sure my quotations are on the. Yeah, I'm kind of off the screen here a little bit, but negative angles. Let me just give you a little insight into geotrig. Positive angles get measured that way. Negative angles get measured this way. Pretend that's a minus sign. Negative goes that way. All right. So negative 210 degrees just means to go this way 210 degrees. So it looks like this. That right there is negative 210 degrees. That's the same as positive 150 degrees. They get you to the same spot. They're the same. Okay. Here's the thing. Your calculator knows the cosine of negative 210, the sine of negative 210, just as it knows the cosine and sine of 150. It's the same. So you don't even have to worry about changing anything. Your calculator will still evaluate it for you. Do make sure we're in degrees, not radians. The newer calculators have the thing at the top. It'll tell you what you're in. The older ones don't. You just have to hit the mode button. But hit the mode button, come down here, make sure you're in degrees. And just cosine of 150, cosine negative 210. They're the same.
Whoa.
Okay, so again, but your calculator knows both of them, so you don't have to convert to 150 or make it positive. Just know that the same thing we did to go from polar to rectangular before is the exact same technique. So in this case, h is going to be 4 cosine of negative 210, and v is going to be 4 sine of negative 210, and they equal whatever they equal. So 4 cosine negative 210 equals 4 sine negative 210 equals. So we get negative 3.46i plus 2j. And there's our answer. Coordinate conversion is what it always is. Doesn't matter how the angles are presented. When you go from rectangular back to polar, I still expect a positive angle every time. The technique I gave you should do that for you. The absolute value on the inverse tangent part. And that makes sure that you get that answer between 0 and 90. And then you either subtract from 180, add 180, subtract from 360, or keep the angle the same depending on what plot you're in. All right, but just keep that in mind that going back the other way is always going to be a positive angle here. But just know if you have a negative angle in your problem, you have the ability, your calculator knows how to do it still. It doesn't change how to do it.